Key objective is to making a low-cost system and easy to be fabricated.
Professor Liang He, who is a NOKOV user and new generation star, led his team to publish multiple research papers and present at ROBOSOFT 2025, focusing on wearables for motion monitoring, motion reconstruction, and rehabilitation.
My name is Liang He. I'm an associate professor in engineering science at the University of Oxford with the Institute of Biomedical Engineering and the Podium Institute for Sports Science and Technology. First thing we're trying to explore is the development of wearable sensors that can also be used to not only reconstruct the kinematics as well as the force and loading conditions of the joint. The key objective is to making a low-cost system and easy to be fabricated. With ROBOSOFT, we published a paper in developing direct ink writing method to encapsulate conductive ink in flexible and soft substitute, in this case in silicon, to make it extra softer, and we could tune the property and sensor design to fit in different design of the variable skins. We've been also exploring the use of such technology with a range of sensing method, including capacitive and resistive sensors for stress and strain monitoring. Working with NOKOV, we've been using their vision-based reconstruction system for motion reconstruction, and this system is using as a high accuracy system to be used in a lab research environment. In this wearable sensing work, there's mainly two challenges. One challenge is the personalization. How do we design something not only having a method that can be fabricated in a genetic method, but as well as being tuned their parameter to fit into personal use and having the same level of accuracy. It is also referred to the challenge in calibration, because when we calibrate such system, especially in the kinematic side, we tend to using a ground truth motion reconstruction system, such as one with a NOKOV. However, when we translate this to users who never wear such system before, we need a new algorithm to be able to adapt to the new users. A second challenge will be landed in the fittings. Wearable sensors in use facing a lot of issues, such as when people start moving, they will sweat, they will having this slack movement between the wearables and the human body, different temperature changes. All those bring in new noise and new issues to the sensor accuracy, and those are the major challenges we are currently facing to pushing the development of such device in more real-world using scenarios. In the case of designing variable exoskeletons, we're trying to using it as a guidance for people to rehab through the guidance of the robotic device. So in that case, the physical therapist can be only required as the guidance of monitoring the rehab process. We will require less effort coming from the clinician perspective. So, as well as exploring new methods such as haptic devices to making these wearables not only as sensor actuators as well as intelligent media that are able to enhance the communication between the users and the virtual agent. We intended to design the AI algorithm to better coordinate such hardware with human, and this will be tested using our humanoid robotics simulators. I lead the healthcare biorobotics lab. In my lab, we have 3 strands of research. The first strand of research is focused on the development of humanoid robotic simulators. This including both the muscle-skeleton system and the robotic organs. The second strand of research we have is on the design of wearable and assistive robotics. In the last strand of research we're working on is for human-robot interaction. I'm very happy for anyone who interested in the field of robotics or soft robotics for biomedical application to get in touch and looking for collaborations. My lab every year we're having open positions for PhD positions as well as master positions. We're also having some positions open for visitings as well as postdoc research positions.